Yeah, I'm John Rezabek. I guess I've been in the process control field for over 30 years now. I started my life back in Cleveland, Ohio, at Standard Oil of Ohio. And not too long thereafter, it became fashionable to dissolve your corporate engineering department. And I was given a choice of like 2 refineries that I could be deployed to if I wanted to continue working for Standard Oil. And I ended up in Western Ohio, in Lima, Ohio, at Lima Refinery. And I ended up doing a job that nobody else wanted to do. That was analyzer maintenance, process analyzers. In a refinery, if you're familiar with the refining business, process analyzers are very complicated and temperamental pieces of equipment that require a lot of attention and care and feeding and maintenance, and usually they're untrusted. But at the same time, the advent of model-based predictive controls was coming into common practice, and those folks really prized having that analyzer information to run their optimizers, to work with their advanced controls. It made them a lot of money. I don't know how many DCS projects have been justified on the basis of FCC light gas oil endpoint. I think we justified at least 3 of them on the payout from that analysis alone. So there's a lot of money to be had there. Well, it came to pass that Gaschromatographs were one of the first analytical instruments that became microprocessor based. And when they became microprocessor based, it became possible to digitally integrate them with the DCS. And all of a sudden, we had real-time indications of data quality. With every chromatograph measurement we got, we also knew, was it current? Was that from a current analysis? Is the GC still think it's operating? We had very valuable information about the quality of that measurement, which made it possible to use that measurement for advanced control. So I guess what I'm trying to say is, early on, I became a convert to digital integration of field devices. If you've got a microprocessor-based device in the field and a microprocessor-based control system, they ought to talk to each other. Well, let me see, maybe 12 years later or so, I was involved in modernization projects, and at that time in my career, I didn't think I needed to know anything besides Honeywell TDC 3000, because that was our standard. We'd been transformed into BP by that time, and BP had decided we're a Honeywell user, and that's our standard. And so I didn't think I needed to know anything besides Honeywell. And Honeywell offered a unique offering at that time. It was called DE. Anybody ever apply Honeywell DE in the audience? And it was kind of a very interesting and compelling technology. And like the gas chromatograph, it offered digital integration of field devices. And you know, there are those who would argue that the Honeywell DP cells and temperature transmitters were not the best solution for that measurement. But what we found, they were up to the task, and we really liked the fact that they were digitally integrated with our DCS. The problem was, it was a proprietary protocol. So if I wanted a positioner that was digitally integrated with the DCS, which had a lot of interesting information to share, that wasn't in the realm of possibility. So, well, let me see, maybe another 10 years after that, BP decided that they wanted to build a new chemical plant in Lima. And we thought, they also, at the same time, they wanted to close the refinery. So we were in the process of working on converting the refinery into a super terminal, and also working on this new chemical plant. And we thought the chemical plant was going to inherit the old DCS from the refinery. Like, we were going to just like scavenge the best parts of that Honeywell system and use them to run our chemical plant. And we're going to deploy Honeywell DE and our other standard for valves. But it also, let me see, at the 11th hour, a buyer came along for the refinery, and they wanted to keep their DCS. So we went on a search for a DCS at that time. It so happened, this was 1998, 1999, that our our primary valve supplier and instrument supplier for the chemical business, felt that Foundation Field Bus was ready for prime time. So we embarked on a project where all of our regulatory instrumentation, all of our DP cells, all of our temperature transmitters, all of our valves, and whatnot in this chemical plant were deployed with Foundation Field Bus devices. And we were fairly conservative and took a lot of precautions and didn't really know what we were going to get. What we found out was that Foundation Field Bus was very robust and did the job. And as it turned out, we deployed control in the field in about 80% of the control loops in that plant. And to this day, all of those control loops are still running in field devices happily. And our plant manager is extremely happy with the quality and the robustness of his control system. What we've also discovered with Foundation Field Bus is that there's a lot of diagnostic information that comes out of those devices, and it's really only been in the last few years that we've tried to become more disciplined about utilizing those diagnostics. And I guess having been trying to practice that for a few years now, the need for better guidance in how best to utilize those all the diagnostic information that's coming out of those devices, both field bus devices and heart devices. We have since deployed MUXs and to bring in the information from all the heart devices that are connected to our shutdown system. So we got a lot of information coming in, but we really the tools that are provided. I mean, there's a lot of powerful tools out there, but we don't see them as necessarily ideally focused on the usability, the things that we need as end users. So we really like the standards effort that's ongoing, that's seeking to define what the roles are on the end user side, and thereby better define what the needs are on the supplier side to provide those tools for the end user. So, thank you.